Hello again, and this is a continuation of the previous PLC testing stations that I'm doing, and built a system here that mimics a small heating and ventilation unit using a small tank with a heater in it and some controllers that controls the diffuser to control the air pressure or volume. I got some sensors installed also for the alarms and trips that's needed to safeguard the whole system. I also utilized the old PLC S7200. Now the heating and ventilation system is consists of sensors like current transformer for the motor, safeties, some RTDs for the hot water and the air supply temps, air pressure sensors, and some other things. The startup and operation and shutdown is listed in here. You can pause and read it. It entails various sequences that continues to go on a cycle so we can meet the set point and have the system stabilized and deliver the right air temperature and pressure. We also have some safeties and alarm that will pop up on the HMI. It includes the motor trip, the overtemp in the water tank, and the leak detector. Now right here I have programmed a set point page, so you can set at what supply temperature or what supply air pressure and the limit of the hot water tank you want to establish, so you can have the system running on what you like it to be. Now you can start it from the HMI or start from the actual buttons. And right now it is running. It's a combination of a fan motor. It's an induced air, and that diffuser there is controlled by a digital to analog converter that opens and closes until the pressure differential is met. And right here I have a small tank with a water heater here that is controlled by a relay, which is programmed to turn on and off in a not in a continuous time, but I made it like on an every 10-second interval to at least safeguard the relay and avoid overheating. I also did the same thing on the diffuser. So because the diffuser reacts very slowly, so I made sure that it is timed in a way that you can cope up with the set point before another command from the PLC or instruction will trigger it, so it won't overshoot. Now I am testing here the current transformer and the motor. And you can see that there's an alarm there. If you pull out the motor, meaning it's working fine. And I have an RTD here that says it's the water temp. If the water temp goes up to 50 degrees centigrade, meaning if the fan or whatever causes the pump to stop and the heating element continues to run because it's coping up with these air supply set point, whenever the hot water tank goes up to 50 degrees, the whole system will shut down. I'm trying to show you here how the air pressure on that small box is building up. Right now we're on like 7-8 pascals, and this diffusers opens and closes. If you turn up the system, this is like a failed to open diffuser, so whenever the system stops, that diffuser fully opens to 100%. I also made a bypass water line here, so if you want to heat up the water faster just by circulating the water more and back to the tank without going to the coils, you can also do that. I have here monitoring the temperatures and the pressures are indicated on the HMI, so you can see it clearly at what point are you now at. This is like the third design that I made, which includes analog signals, and it also involves the actuated devices such as diffusers. There are some complications at first when I'm doing this, because connecting this PLC to the diffuser, because it needs to pass through DAC or a digital analog converter, I need to do some tweaks on the DAC to change the offset and some spans just to cope up with the right settings. I also programmed some scaling so I can have the right temperature, and did some measurements just to calibrate it to the right one. I hope you like this one, and if there's any question, just let me know. Thank you.